A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. Have you ever observed when viewed through a water drops that fell on the newspaper or magazines, the letter appear to be bigger in size? Why is it so? We have discussed refraction of light and its wide application so far. In this session, we are going to discuss an object which can be considered as one of the greatest applications of refraction. They are lenses. It is generally accepted that the origin of lenses can be tracked back to the ancient Roman philosopher Seneca, who described letters could be magnified by a ball of crystal about 2000 years ago. Optics, the major branch of physics itself, began to grow after the development of lenses by ancient Egyptians and Mesopotamians. A lens is a transparent medium having spherical surfaces. These are usually circular in shape, having two surfaces that are grounded and polished in a specific manner designed to produce either a convergence or a divergence of light. Mainly, there are two types of lenses, convex lenses and concave lenses. Both can be considered as spherical lenses. In one perspective, lenses are formed by the overlapping of two transparent spheres. Let us consider a convex lens first. In the convex lens, the transparent surfaces are bulging outwards. The lens is said to be formed by intersecting two transparent spherical spheres side by side. If we consider a concave lens, both the spherical surfaces are curved inward. So, if two transparent spheres are placed near each other, the space between them is said to form a concave lens. Now, let's see the important terms and characteristics of both convex and concave lenses. There are many points and distances related to lenses that you should understand. The first one is the optic center. It is usually known as the pole of the lens. It is the midpoint of a lens which is denoted by the letter P. The next one is the center of curvature. As we have seen, a lens is said to be formed by two transparent spheres. So, they have two spherical surfaces. Center of curvature is the center of the imaginary spheres of which the sides of the lens are parts. There are two centers of curvature for each lens. They are denoted by the letter C. Another important term is the principal axis. This is the imaginary line that passes through the optic center or pole joining the two centers of curvature. As of now, we have seen two types of lenses and some of their characteristics. What happens when light is passing through each one of the lenses? Or what is the basic difference between refractions happening in them? Let's see. Here you can see a convex lens. Light rays are coming from the left hand side of the lens and are parallel to the principal axis. After refraction, you can see the rays converge at a particular point on the optic center to the right hand side of the lens. Therefore, a convex lens converges the light rays. The point of convergence is called the principal focus. It is denoted by the letter capital F. On the other hand, if the light rays are coming from the right hand side of the lens, they will converge on the left hand side and the principal focus will be formed on the left hand side. That is, since there are two refracting surfaces, two principal foci are there. So, we can say that a convex lens has two principal foci on the both sides and they lie on the principal axis. We have seen that the light rays are converging after undergoing refraction through a convex lens. Now, let's see what is the difference in case of a concave lens. A concave lens is placed here. Light rays are coming from the left hand side of a lens and are parallel to the principal axis. After refraction, the light rays are diverging away from the principal axis. But if we extend these rays to the opposite direction, they appear to converge at a point on the left-hand side of the lens. We understand that it is impossible to converge light rays to a single point using a concave lens. Therefore, the principal focus of a concave lens is virtual. As in the case of a convex lens, concave lenses also have two principal foci. Both of them are virtual. Another important parameter about the lenses is the focal length. Focal length is the distance from the optic center to the principal focus. Focal length is denoted by the letter small f. If the thickness of a lens is much smaller compared to the radius of curvatures of the lens surfaces, this lens is called a thin lens. The lenses we are discussing in this chapter are thin lenses. So, in this session, we have learned the type of lenses and terms and characteristics associated with lenses.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS The Learning App.